Wow.
Kevin's just walking in.
My card works now.
Yeah,
Nice.
They let you in.
you did?
Oh.
You got it today?
Oh, I had my card for a while, but it would open.
Activated.
But you do not have key.
No.
I have the key.
Come sit here a minute.
Hey, Soggy.
Ah, hi, Lindsay.
So some people did make it to the lab. Apparently, I should have continued on my bus.
Good job. Good job. Oh.
Actually,
Nice.
I was on the bus. I made it to a bus with no people, and then I saw the message, so I just turned after 2 stops. I turned home.
Fair enough.
I think that's a good choice, I guess.
Yeah. Well, the only issue is that there's no food on campus. All the restaurants are shut down.
Yeah, that's it. Yeah. So I didn't want to take the risk to be there, have no key, and then be in front of a closed door.
Yeah.
Yeah, totally.
Hey,
Hey,
babe.
Ben.
Oh,
Your mic is off.
I don't think you're muted.
Hello.
Hey.
Yeah.
There we go. So there's a lot of people here that you probably don't know. So there's been some folks who've joined at UBC. So might just start with quick introductions, if that's all right. So how about UBC folks start, if you are at UBC.
Yeah.
Okay.
And then we'll jump to Sarah.
Exactly. So you guys, I think we'll introduce. I'm Dom. Then we have.
Hi, I'm Kevin. Yeah, I recently started as a research assistant with Doug at UBC. Yeah, I'm trying to do this hydrogeophysics project in Myanmar with, yeah, that's all I'll say.
Vahid.
Yeah, I'm Wahid. I have my own graph and gravity-magnetic data from a geothermal source. And actually, in my sabbatical period, about 1 year, I just started to work with SimPEG, of course.
This morning.
Yes,
this morning. First version.
Yeah. Actually, I installed it this morning. Dom did a great job for me, and now I'm preparing for modeling my data graph mag in SimPEG environment. Hopefully, of course, I actually modeled it in by Graph 3D and other softwares such as other methods, Camacho, Model Vision, all of them. And this will be a good comparison between SimPEG results and other methods, hopefully.
Nice.
And yes, this is actually my main task here, that to model this data, graph mag, and it's a nice data, fine data from a geothermal resource in the center of Iran. So we will see the results after some time.
Very cool. Sarah, would you like to jump in and say hello?
Yeah, I just have my daughter here. Sorry, ik ben hier even aan het werken, dus dan kun je maar bij papa blijven. Waar is papa? Yeah, sorry. So, yeah, I'm Sarah. That was my daughter, Sue. And I just started at UBC to work also on hydrogeophysics, so to use SimPEG to invert agricultural data with ERT and EM. So, yeah, and I'm also happy to help with the development of the GPG website.
Excellent. And then, Bane, do you know Soggy and Thibaut?
We've met briefly.
Met briefly.
I met Soggy at least. Tigo? I'm not sure I know who that is.
Thibaut, do you want to introduce yourself?
Yeah, hi Ben, yeah.
Okay.
I was at the meeting where you presented all the cool stuff with VTK, but we never met in person, I think. So I'm a PhD student at UBC with Doug.
Oh, awesome. Cool.
Excellent. And then Bane, would you begin to introduce yourself?
Yeah, for those that don't know me, I am a student at the Colorado School of Mines in the geophysics department here. And I've just been working on a lot of software for visualizing geoscientific data and just discretize and SimPEG in general. It sparked my interest as a really cool framework for finite volume problems. So I've just been sort of diving into the code where I can, and I'd like to share what I'm up to in the visualization realm with you guys, because I think a lot of you could benefit from it.
Yeah, that's great. I always used ParaView with Bert and Gimli before, so I love VTK.
Awesome. Yeah, and there's been some exciting development with some of the VTK stuff, so we can totally avoid ParaView altogether.
Oh, that's great.
Wow.
Yeah, so I'll let the meeting continue and then chime in later with those details.
Okay. So I think we've got a handful of items to go through. There is a new Gravity app in the GeoSci labs that has been added by some of DQuant students. So I think Thibaut is going to give us just like a quick run through. There is updates from Bain, which I'm extremely excited to hear about with respect to VTK and a new pull request that he has been working on. And then Sarah, I believe that you added a couple of points with respect to
it's from the discussion from yesterday, yeah, but yeah, if we have time, of course, otherwise it's for another time. Okay,
sounds good. I think let's actually start, Bain, if you're game to go first, because I think this is probably the most one of the points where we're going to have the most discussion. Okay,
awesome. I didn't really prepare anything too formal because sort of the meeting was happening and sort of last minute I was like, I need to share this with everyone. So I guess I put that link up for that pull request. I'm just going to pull it up on my end and try to share my screen here in a second. Wow, I should have pulled this up earlier.
That's all right.
But yeah, so if you go to that PR on GitHub, you can see the image I made there. Does everyone pull that up? And I'm gonna run some code here in a second and try to get this on my side.
Well, otherwise, if they need some time, we can do something else in the meanwhile, and then he can prepare, because otherwise it's.
I am almost here. Cool.
Okay.
I am just going to figure out how to share my screen now.
So it should be, if you mouse over on the left-hand side, there's a green screen. Excellent.
All right.
Yeah.
Cool. So I am just running off of the docs that I built locally on my computer for Discretize. But I put together a little example of how you can use VTKI and Discretize to visualize an entire scene in pure Python. So this example right here should be able to work on Travis. It should be able to work on anyone's Jupyter notebooks. It should be good to go. So in VTKI, there's just been a lot of recent development to basically with all these different IPython tools that we've been working on. So this, I've jumped over to the VTKI docs, which you guys can go to with vtki.org and find yourself. But just all types of things where we can just use these different tools like orthogonal slicer, pass in a VTK data set, and have like this nice interactive rendering that pops up as 3D. You can move it around, do all types of cool stuff, and then widgets to control different like filtering things or display parameters, all of that kind of stuff. So I just wanted to bring this to everyone's attention that these tools exist. And if you use the 2 VTK methods I put in Discretize a while back, those will spit out VTKI data objects, and you can just get started doing stuff like this pretty easily with a few lines of code.
So that's great. So, sorry, go ahead.
So I was just wondering, what are you actually using to render this? Like, did you actually write 3D visualization code, or are you leveraging another package? What's the thing on the right?
Yeah, this is all VTK. So VTK, it has Python bindings. So everything you can do in like ParaView or just in C++ with VTK is totally possible in Python. It's just pretty cumbersome to do it. So in VTKI, that package, we've been working towards making an interface back to the VTK library that's more intuitive and more Pythonic. So with this is your VTK, we're just basically setting up a bunch of routines to create renderings in a much more intuitive manner. So if you wanted to do just like plot kind of like you would in Matplotlib, you can just say vtki.plot.
Yeah, that's cool. That's really, that's a big advantage because you can do it directly in the same interface, let's say. Before, I always had a problem with this visualization that you have to write these text files and import them in ParaView. It was just,
Yeah, it's a pain, and then you upgrade ParaView and those state files don't.
Yeah, they don't work anymore. So yeah.
So we're working towards making all your visualization reproducible, so that you can write these scripts using VTKI to create your render environment, save screenshots, and just be able to run through the same routine, get the same 3D image every time. And it's, we're not trying to reinvent the wheel. We want to use VTK for all the rendering engine for all that because it's so robust and sort of vetted.
This is really cool.
And so in terms of input, what do you need there? So because I remember for VTK you need some kind of special format. So if you get your output from SimPEG, let's say, of some kind of inversion, what kind of format do you need to be able to use that?
So if you're running in SimPEG and you have all your meshes in discretize,
then it works.
Yeah, so say we just had some discretized tensor mesh, like here. And so in this example, I put in the pull request. We just download some tensor mesh, and we have now just a tensor mesh object in discretize. We can use the toVTK method if you have VTKI installed.
I see. Yeah.
All that is install VTKI, and then this method will appear on your mesh. And this will just spit out a Python VTK data object. So there's no like file IO going on there or anything like that. You just grab that VTK data object right there in memory. And start working with it.
Super slick. Sagi, you had a question?
Is that only working in 2.7?
No. Python 3 would be preferred. Yeah, so all this is Python 3, and there's some issues on Python 2 on some OSs, but you should use Python 3.
Yes, absolutely.
And so what's the kind of plan for PVGO then? Like, are you is that kind of parallel with PVGO?
Yeah, so VTKI is really sort of all the visualization code. So how do we actually take VTK data objects and visualize them and make renderings and apply like really common VTK filters? That's all handled in VTKI. And then PVGO is sort of tangential. It's just a bunch of sort of what are called algorithms in the VTK framework, where they take inputs and produce outputs. So PVGO will just provide a bunch of file IO functions for geoscience-focused data sets, as well as different filtering algorithms sort of designed to transform VTK data objects in a geoscientific context.
Okay, I see.
So yeah, so the all the visualization stuff is going to happen in VTKI, and then PVGO just adds a bunch of tools for transforming your data.
This is super cool, Bane. One question I have for you, putting my Jupyter hat on, is like, are there things on the Jupyter integration side of things that we could support you on or like help figure out? Are you running into any roadblocks there?
I think not really. I would love to find a way that we could put the rendering window in the Jupyter lab, like inside of a separate window.
Yeah.
Like in the browser somehow, so that way I don't just have some pop-up window that's separate from the whole notebook environment thing. That's really all I see happening right now.
Okay.
But I think there's just like a bunch of ways you could do that.
Well, I'm happy to ask around here and ask like what is the preferred way to perhaps do that. Because I don't know offhand. But it could be something like I'd imagine perhaps writing like a magic, like what the matplotlib inline does.
Yeah.
Something potentially like that.
Yeah, and that's sort of what we have now in VTKI, where if you just do kind of like the equivalent of inline,
oh yeah,
with this notebook true flag, which is on by default, then it just produces a static image screenshot of the rendering environment. But we can make that false and then pop out that window.
Oh, okay.
But yeah, sometimes I don't know what to do with this window, and I've had a lot of people really want this to be in the notebook so they don't have to do that all the time. But that's all I can think of.
Wow, cool.
That's pretty cool.
Super
cool.
Yeah. And I guess I could run that example if you guys want to see it.
Yeah.
Yeah, absolutely.
Cool. Why don't I just copy and paste all that code? All right, so I'm just running the example I put in the pull request. It's just downloading some data from one SimPEG example and one other discretized example. So I just kind of piggybacked off of those data sets. So now I got a mesh object. I just have some tensor mesh and a whole bunch of data attributes. So in here, I just convert my tensor mesh over to a VTK data set. And then I also load in some topography that I got from one of the examples, which is just a text file with XYZ arrays. And then I pass those points over to VTK to get a poly data object, which is just a way to represent those points in VTK. I apply an elevation filter to get like a value for what my Z component is. Then I do the same thing with the actual gravity data used for the inversion that was given in the example. Same thing, it's just XYZ and some attributes. So I just create some more poly data, pass in those XYZ points, and then pass those gravity observations. I didn't really look too much into what those data values actually were. But I'll just go ahead and run that. So now I have...
Bane, what was the elevation filter?
So the elevation filter, it basically just takes any input data. We have all these filters that are binded to all the VTK data objects. And if you call these filters on them, like the elevation filter, it runs its algorithm on that object and spits back the result. And then the elevation filter takes, there's all types of different filters, but it takes your input data object and then just adds a like scalar value for what the Z component is, or you can define a vector to sort of put as your mapping array. But it just adds in an extra attribute that basically just says what my Z values are on this topo surface.
Okay, got it. Yeah, got it.
Yeah. Cool. So I did that. And yeah, now I have a whole bunch of VTKI data objects, so I can print those out. So I have the data set, which is, again, that tensor mesh that got converted. If I just print that out in the notebook cell, it's just a rectilinear grid, and I have that LP out data array on it. So I can pass this data object to any VTKI plotting algorithm or plotting routines and immediately see that result. So I can just say dataset.plot. So like I just converted from that to VTK method, and then I can just say plot, and I have a 3D rendering. And again, you can say notebook, it's false, and pop it out here. So yeah, so there's that. I can also apply other filters. So I mentioned the elevation one. There's the threshold filter. And again, these are all just binding. So here I just threshold the data set to get rid of all of those NaN values that are in the mesh above the topography, like around there. And just set up some different plotting parameters to make the background white and different grid lines black, stuff like that with this line of code. Create my plotter. I add in my axis bounds. I want them on the outside. I got a grid, looks good. And I can add in, I can again apply more filters to my thresholded data set by just calling like dot slice or another threshold dot threshold and create like a volume. And I will just say notebook equals false. And there's a bunch of different plotters. So like right here, I'm using vtki.plotter. There's other ones like background plotter. So that way I can have a window out to the left and then edit it with like 10 different cells. But this one is a pretty simple, whoops. That's in the wrong one. So here's my rendering of the whole scene.
Wow, that's cool. Wow, that's cool. So, Bane, is there a way that I can load it up into ParaView at somehow?
Yes. Getting the scene, the whole scene, like with your display parameters and all that set, would be challenging, but it's possible.
Okay.
And I've been trying to think of a different, like whether or not in VTKI we should, put a script that will export the scene to something ParaView can see. But each one of these data objects we have rendered in here all have a .save method on them. So I can say data set, which is again that tensor mesh that we had originally. And since it's a VTK data object, VTKI data object, we have a save method. So I can just save it out.
Oh, I see. So at least like I can just load that VTK files up in ParaView.
Yeah, so now I can launch ParaView and I can just drag and drop that file
cool.
straight in there. So you can do that with all of them and then readjust your plotting parameters. But
right.
That's where it is right now. Another option is if you want to share the visualization you made, VTKI. Let's see here if I can do this real quick. So again, I'm just going to create this rendering scene. I can take that plotter object I have as P, and I can just say export VTK.js, and I can say just make a new file. Now I have this new scene.vtk.js file. And I can go to a little viewer I have set up for PVGeo that can open that. And you can share that file or link to that file or the scene with anyone. And they can view it in a web browser. So I'll just do this. And now I have that same scene open in a web browser.
That's crazy. Whoa. That's crazy. Can you, like at one point you kind of asked about the sort of time-lapse images. Let's say you got 10 iterations of gravity inversion, for instance.
Yes.
Like, can we do that in VTKI?
Yes. So yeah, I'm working to put more examples up of how you might do that.
Okay.
There is code in the doc somewhere I could point you to, but it's as simple as putting in a background thread with like a loop, like a while loop. To iterate over and over all of your different models and just update the scalars in the scene.
Right.
Yes.
Wow. That's slick. Wow.
I don't know if I have. Yeah, I don't think I have an example pulled up, but I could point you to one.
Right. Sounds great. But if you generate the time lapse sort of stuff, can we render into VTK.js as well? Is that possible?
I don't think so.
Okay.
I don't think VTK.js can handle the time-lapse stuff. I actually haven't played around with that at all.
Okay. I was just wondering. That'll be really cool to share.
Yeah. Yeah, so lots of exciting stuff happening with the VTKI.
Yeah, it does. I'm pretty excited.
Anything that's happening over there just immediately works with Discretize. So
That's so exciting, Bane.
Yeah, that's really exciting.
One other question I have for you is, I guess, like in the viewing world, because here we've been poking around a bit with getting other web apps and things like that launching easily inside of Jupyter Hubs so that you can share basically any sort of web app through a binder. Sorry, I'm just going to mute you if that's all right. I'm just getting like your mouse clicks, so feel free to unmute things. Yeah, so like getting things launching into Jupyter Hubs so you can share like a 3D visualization through something like Binder. So we've played around just a little bit with like some of the ParaView web apps. I don't know like what your take is on where those things are going, like the VTK.js evolution. Like there's a lot of players in this space, and like I'd just be curious sort of what your take of the landscape is.
I think VTK.js has the most promising sort of future development ideas going on for like what would be possible in a notebook. I'm excited about what I'm seeing over in that library. I haven't played around with any of the like ParaView Web or any of those web tools just because there's a lot of overhead to get them sort of set up. I just haven't had the time to sit down and set them up. But yeah, I think VTK.js has some really exciting stuff happening. But like right now, all they display is image data, which is like very uniform grids. So we'll see, but we'll see when they can handle other formats. But yeah.
Super cool. Well, thanks for taking time to show us that, and we can iterate on the pull request. But like, I had a quick look, and it looks really solid. So I think we can get that in pretty quickly.
Cool. Awesome.
Yeah, and I guess the other update on the Discretize side of things is just I've been working on getting the docs pull request up and running. AppVeyor is failing right now, and I don't know why. So I'll take a look at that. But hopefully we can get that in as well, and then start, iterating from the more nicely formatted docs.
Awesome.
Cool. Any other questions for Bane on the visualization VTKI side of things?
Yeah, I have one for you, Ben.
Sure.
We are currently kind of missing the octree vector to be able to see vectors on a octree mesh.
Okay.
How hard does that sound on your side?
We have some code that will work with vectors. I haven't touched it in a while, but I think we could get it up and running pretty easily. So like if you just have like an array on your mesh that has just like 3 components, then we can plot that direction and then I guess color it by a scalar value.
And VTK, what kind of, have you seen the vectors in VTK, how they look? Do you have choices or?
Yeah, you have choices. I've always seen them as arrows.
Okay, but you have it. Sounds good.
Yeah.
Sweet.
Yeah, so I'll get an issue going for you on that. And
Sweet.
Feel free to start your own on there to help remind me.
Will do.
Excellent. Any other questions? No? All right. I think maybe the next item is, Thibaut, would you mind doing a quick tour of the new notebook that has been added to GeoSci Labs? Just note that, yeah, you're muted.
Yeah. So, can you see my screen right now? Hello?
You got it, man.
Yep.
Okay.
Yeah, you're good.
So there is a pull request from a DQuant student right now for 2 gravity apps. So one is for a sphere, one is for a dike. So they're like the notebooks are fairly simple, like but they added the text that is required, like so an introduction. What are the parameters? I like that they added the a little sketch to explain what things are doing. And so that's what things look like right now. And I kind of like you have the option that if you want to keep your previous plot or not to compare. So either you have your latest one, and it's fairly quick, so we can change things. But if you activate that, you will keep your previous plot on top of your new one. And so and you see the data at the surface too. And they have this option where they like just output the data, so for a simple copy paste. And the Dike app is pretty much the same thing, but for a Dike, you have a lot of options for the Dike, for the orientation, etc. So it's really cool. It works well. I think really the bottleneck right now for that PR will be really the code formatting. Like there is not much. Like do I have it open right now? Yeah. So like my linter is just screaming at me just opening the file, as you can see.
Thibaut, a lot of that, so now rather than like us manually checking, should be taken care of by the make format and then make check. So make, there's two things going on in there. The make format actually runs black, which is a code formatter. And I think this is something that we should start considering doing throughout the SimPEG ecosystem, because it like at least treats all the code uniformly and like opens and is like opinionated about where brackets and things like that are. So it just automates all of that, so we don't have to worry about it, which is nice. Then the make check also runs Flake 8, which is basically like a light PEP 8 linter. So it's not as strict as like, I forget what the other one is, Pylint. Pylint is like quite strict. It would be nice to get Pylint like passing on something like SimPEG. I wouldn't worry about that level of detail on the GeoSci labs. That code is much more sprint code. So I think like when evaluating, you know, if it passes the make check, so the light PEP 8 linter, and as you look through it, you find the code to be reasonably readable and variable names make sense and all of that sort of stuff. Like that's probably a high enough bar for this repository. Does that jive with you?
Yeah, no, that sounds totally fair. And that's basically what I told D1 student in the PR. Like I will really do a more in-depth review once all the Travis tests are passing, and you give them all the key for trying the make black. So I'm just waiting for them to come back to us and see if they have any question. They can contact us. Just like I'm just waiting for that things to be done before diving much deeper into the things. But things are looking good.
That sounds good. And then two, as you're reviewing this, one thing that might be worth us thinking about is actually having a bit of a checklist for reviewing the notebooks. So like I'm an editor for JOS, for example, and there's like just a reviewer checklist when you're going through the repository. It might be worth us like synthesizing a list of, 10 things that we're asking for or whatever to help streamline the review process and make it a bit more uniform and like clear what our expectations are.
I think that's fair because like D1 student made that pull request, and like I made a fairly long commenting of like all the good, but also saying like, okay, that's what we expected to see. Like so that could be a base to start. So for example, there was like no comment at all in the code, so it was really hard to see what was happening, or also the styling, etc. So
that's
and as I say, like good thing is that I love that they made all the sketch as we did for our notebooks. So I think that will be another requirement, because that's so much more helpful than just the list of parameters.
Yeah, completely agree. So maybe one thing that we can do, and maybe Thibaut, you and I can iterate on this in an issue, is just like outline a bit of a checklist for the notebooks, as well as perhaps for the code, and like just try and be a little bit more explicit about what our bar is for when a pull request can be merged into this repository for like a new contribution.
Yeah, that pull request will be perfect for that.
Excellent. Cool. Does anyone have questions, thoughts with respect to GeoSci labs that you'd like to bring up right now? Note that you're all muted.
Oh, yeah, just kind of naive question. Maybe, is there any context around what this is for? Is it meant to be an educational tool for students, or maybe if you could comment on that?
Well, so I think there was a double goal for DIC1 for even triple. I mean, gravity was really a missing milestone in all the notebook we did. We did magnetic, electromagnetics, MT, etc. But we didn't have any for gravity. So, and that was asked by DIC1. That was asked by Alini, I think. So it's good to have it started. So also those notebooks are developed by DIC1's new students. So I think he made it as like a course project for them. So that was like also educational in the way of the development was educational.
Oh, okay, I see. It's killing multiple birds with one stone.
Yep.
Cool.
And after that, the use of that those specific notebook in the long term, well, it's kind of like 350. You need to build a class around that. So I guess DIC1 is that's what DIC1 is doing, but that might be a bit more specific.
Okay, great. Thanks.
Yeah, it'll be nice to integrate those functions into GeoAna, I guess. Look at that. The gravity function is actually in that GeoSci labs, or is that correct, Thibault?
Yes, actually, thanks for reminding me this, Sogi, because that was one question I was planning to ask you during the review. Is that so the gravity in GeoSci lab right now, the way it's developed, so it's self-contained. It's all the functions are in extra, so it doesn't depend on GeoAna or SimPEG at any level. It's everything is in the GeoSci lab. So I think that was a good way probably to go for DIC1 student, because they were developing it also as a like academic project. But in the long term, that makes like this thing that is completely disconnected from all the other package. So maybe in the long term, that's not what we want. But right now, yes, it's self-contained in GeoSci lab.
Okay, sounds good.
Yeah, I think that's a great point, Thibault. I don't think it's a pull request blocker at this point in time. Like, I think it's totally fine that the code is sitting in GeoSci labs. But maybe one thing that we can do is start an issue over on GeoAna. And then like we could help scope out what that code should look like, because it'll probably need to be refactored to like jive with the way that GeoAna is structured. But we could basically like flesh that out. And then if DIC1 or any of his students are interested in contributing at that level, if we've sort of laid out what the structure is and what needs to be done, then it's a lot easier for them to jump in and just like start cracking on it.
Yeah, agree.
Super cool. Any other questions on that? Thoughts? Cool. Okay. Thanks, Thibault. And thanks for taking charge on the review there. It's really cool to see. A couple other things to note on the GeoSci side of things is Thibault is now an admin. Congrats, Thibault. And so Thibault is willing to help just like keep track of users, like who should be added to the GeoSci org, and help field pull request reviews and things like that. So feel free to reach out to either of us if you have questions about where things live, or like if you're interested in also taking on some responsibility in there, just let us know, and like we can chat about making you an admin as well. Want to be inclusive and sort of spread the load and the workload there. So it's good. Sarah, would you like to jump in and talk a bit about some of the points you've made here with respect to, is it REDA as well as student projects?
So it's just two things I put in the doc. I don't know whether you still have time. Yeah, I think it's okay for a few minutes. So yesterday during lunch, we've been talking about a lot of stuff that would be interesting to do while I'm here, and also linked to what you're already trying to do with GPG. And so one of the things was, Doug was asking me, okay, what's still missing, what a student needs when he needs to do, for example, his student project with an inversion code and so on, which kind of information is not yet available, and also in terms of code. And one thing that immediately popped into my head is also the data processing side of things. So even if before the inversion, I'm talking again of ERT, but I think it's the same in other data, other geophysical data, is the fact that we, in different papers, we all use our own filters, and okay, more and more people are at least reporting it, but even there's still a lot of papers that people even don't mention what they did to their data before they inverted them. So I know of a little project that colleagues of mine in Bonn started, that you probably know of, the Gimli side of the world. So that's Florian Wagner and Maximilian Weigand of the University of Bonn, and they started this REDA stuff. So it's also on Git. It's a package that I want to develop with code to process electrical data. So it's rather large. It's meant to be useful for ERT, EIT, SIP, EM data. So everything that's electrical. And the idea was, but it's really in the beginning stage, to develop scripts in Python that would help process data, filter data, and help people do it in a standardized way. So I was thinking maybe we should talk to them and see whether we can join the project and also make it compatible with SimPEG. I don't know. In any case, it's something that I all the time have to do. And once I know how to code in Python correctly, I would certainly want to put my stuff also available in REDA. So for me, it's just a question now in the first weeks to get used to how you guys develop code and be sure I do it in the right way. But then I would certainly want to be the bridge between them and you. And I would think it could be useful to maybe schedule a meeting in a few weeks with them even, that they explain their goal with that package, and then see how we could contribute.
Yeah, excellent. I think that would be great. As much as we can integrate and reduce duplication of efforts, I think that's a good thing. And so if we can actually have like processing level code that operates both with Gimli and the SimPEG world, that would be a really exciting thing. Absolutely.
Because that's the idea. I think it's also a bit limiting that, of course, after the filtering, it spits out some format that works with Gimli, but of course that's probably then not working with SimPEG. And so we should find a way that people can use like data processing standards across code, so that we just have a community level standard of data processing.
Mm-hmm.
So yeah, it's probably more like a long haul thing, but I just invite you to take a look at what I already did and maybe let it work in your head, and you probably have your own scripts already for your own data processing. So I think it's not such a big effort actually. It's just that we need to be sharing what we all do individually at the moment.
Yeah, we don't usually process the data, I guess. So we're probably much lacking in that part.
You never process. So the problem that I have with ERT is often that if you don't process, the data error is resulting in bad inversions, and then So I want to run error models on my data, and then try to do filtering. Of course, then you need reciprocal data and things like that. So it depends also on the type of data you have. But.
Right. So that's something that we don't have in SimPEG at the moment. And well, like at least in UBC, we haven't really dealt with a lot of like a kind of that level, like a low data level. So we kind of that's.
I think the problem or the thing is that often when you're doing geophysics at the geological level, so with big electrode spacings and so on, you have this problem much less than in cases where, like my cases, where you have 20 centimeter electrode distance, and when you have a misplacement of 1 centimeter of your electrode in your mesh, you already have a lot of error popping up there. So So, but that doesn't matter. That doesn't mean that it's not important also at other scales. So yeah.
Right.
Where is John's project, guys? John at Diaz, right? He's working on processing software. What's
there's another guy. Okay, which John is that?
John Kutai from DS.
Okay,
it's a geophysics company, so they do DCIP mainly.
Oh, it would be good to see what they are working on too. Yeah, because I think the issue is not only about having scripts, because probably people have their own things, but the issue is about finding standards that could go for different types of data and on which the community can settle. And so having such a project which is open source would certainly help, I think.
Yeah. I think it's going. So we have stuff in the SimPEG processing. So I mean, there's probably a potential sort of a connection here, but at the very a simplest level, if our RADA can handle, let's say, I/O part rather than just exporting to PyGimli format. If you can export to SimPEG format,
probably we just have to write some script to it. Yeah.
Right, that's actually a good start. Right, so all the processing work done here in RADA can be transferred into whatever other codes, which is actually a good start, I guess.
So I'll put that on one of the first things I want to do. So once I know how to import my data and how to code a bit with SimPEG, I'll contact them. That will be probably in a few weeks, and then we can have a common meeting. Will probably be at another time because this is when they're sleeping. But
yeah, sounds good.
Is that okay for you?
Absolutely.
Yeah, that's good. And it seems like the scope of the RADA is it seems like a DC and IP. Is that correct?
Well, it's all electrical data, yeah. So it's not yet for other type of magnetic or gravimetric but that doesn't mean it's not possible. I think they're really welcoming inputs. Right now, it's really their own first thing, but they really want to work to make it a community effort.
Sounds great.
Yeah, and I think that this is really timely as well, because we've been talking about getting our data class into better shape in SimPEG. And so that actually then sort of defines how I/O to SimPEG will work.
Yeah, probably, yeah.
And I think too that the Pangeo project is a group that we should look to for how data is being stored. They've done a lot of very good work about promoting standards that are easy for modern languages to work with, and that actually scale to the cloud if you need to do a really big computation with big data.
Okay.
And so those are where things like ZAR, what Dom, we were talking a bit about that earlier, have ZARs come out of Pangeo. So those are things to sort of keep on the radar. And so feel free to initiate conversations and get us all going there. Feel free to actually, if you want to even create an issue on the SimPEG processing.
I don't know how to do that now. So that's what I mean. I think I need a few weeks first to get used to your whole workflow of things, and then I'll probably be able to take that responsibility. Yeah.
Yeah, for sure. Well, feel free to ping when you sort of want to get some of those things in motion, and I can help screenshot and show you sort of where things go, or anyone else at UBC can help get you up and running there.
Okay.
Yeah, connected to that. Actually, I'm working here in California. We got actually quite a few airborne data sets, and so actually handling those airborne data is not trivial. So I actually want to have some sort of data structure that can handle airborne electromagnetic data, and that actually are sort of large scale. So I mean, that's something that I'm sort of interested in and kind of need to do anyway.
Okay, so that's actually connected indeed. So probably what would be great is if we could say, okay, we're interested in RADA, and we can have this conversation also with Florian and Maxi, what's their vision on this package. If they would be interested to have other types of data also inside, we could have like a responsible for each type of data connected to what you're doing anyway, and the type of filtering or processing you have to do anyway, and then we can see how we deal with that, okay? So yeah, let's say it's for next month, something like that, okay?
That's good.
That's good. I just dropped another link into the chat window, and I'll toss it into the notes too, on X-Array. So this is something that is worth looking into, Sagi, with respect to handling large data. And yeah, so it's something to start exploring there.
Sounds good. Sounds good.
Cool.
Okay.
Any other questions or comments on the topic of processing from anyone? Nope. Okay. Any last topics, things like that you would like to bring up, or items that you want to make sure that we talk about next week?
I actually just got a quick question to Dom. So what I'm doing here now, actually I'm developing the airborne simulation code for time domain, but kind of geared toward large scale. So the missing ingredient to me now is the like a kind of mesh to mesh interpolation part. I was wondering where are you on that, and kind of can you point me where are you working on it, or what are some of the good resources that you have?
Yeah, I think we're getting pretty good. I think we're pretty mature in terms of the tile map. So I think I'll just do a small PR just for that mapping, and then you'll be able to grab it.
Right.
Because after that, once you have the tile map, it's just you're just stacking your misfit functions together, right? So it's all this. The rest is pure SimPEG. So yeah. I'll just do a small PR for it, and then we can push it quick.
Sounds great. Okay. Yeah, actually, like in Stanford now, there are quite a few people using SimPEG now. So I just want to let you guys know. So Meredith, she's working on seawater intrusion, and she has actually got a lab set up that kind of actually sort of doing a scale modeling of the seawater intrusion. So she's actually using our DC code to invert that data, and actually the results look pretty good. So people are pretty happy. And Ian in here also using the EM code. So he's actually also working in the seawater intrusion problem, but the application is airborne. But there are their usual code is 1D code, but the effect is there are actually 3D effects. So she wants to explore what are the 3D effects in the data. So I mean, like it's actually more people in Stanford is actually using it. So I just want to let you guys know.
Right on.
That's excellent. All right. Unless there's any last things that people want to talk about, we can wrap up here and connect next week. So feel free, if you have any like follow-up items or things like that, or thoughts from the meeting, feel free to add to the notes, and then we can use that as a starting point for next week.
Ben, can you share your notebook?
It's in the pull request, right, Bane?
Yeah, so that's it's in the pull request, that code. I'll just post a notebook as well, just because. And
sounds great. And the time-lapse one as well, if you have.
Yeah, I'll make one for you.
Perfect.
Cool. And I guess Dom, if you could send me just a super simple tree mesh with a 3D component, like what you would want to visualize. If you could just make a simple one and share it with me, I could put some code together to do it.
Beauty. Yeah, I'll do that now.
Cool.
Thanks, man.
Yeah. All right.
Just one last thing too. Yeah, for next week or the week after, it would be great to have see Vaid or Sarah's research or what they want to achieve. That's still something we need to see.
That's a great suggestion, Thibaut. We can follow up.
You've been listed.
You've been enlisted, Vaid.
You've been listed for the
People appointed me.
Yeah, exactly. So we can figure out a time. It doesn't have to be next week if that's too soon, but if you'd be game to, it would be great. And because that can help us figure out what kind of things we can point you to and where we can support you. Sarah dropped off, so you're the first one pointed to.
By default.
Yeah.
All right.
Cool. Thanks, everyone.
Okay.
Have a good week.
Yeah,
Bye.
Bye bye.